And tonight we start talking about spheres. Spheres are balls. They're 3D solids made up of the set of all points that are at a given distance from the center point. So it's a three-dimensional circle. One term that we are going to need to make sure that we um, recognize and understand is what's called the great circle. So in a three-dimensional circle, we have the ability to cut our circle through the middle of it. And if we were to cut it through the circle, the sphere at the top, we would create a smaller circle than if we were to cut it, further towards the middle. So if you kind of think of like lines of latitude on the Earth, the circle that creates the line of latitude near the poles is a smaller circle than the equator, which circles the globe in the middle. That middle circle is called the great circle, the largest circle, two-dimensional circle that's created by your sphere, and it has to include the center point of the sphere. We're going to use the diameter of the great circle or the radius of the great circle in all of these formulas, not just any radius, but the radius specifically of the great circle. There is no lateral area formula for a sphere because it has no sides. So there's no way to just find the area of just the sides since there are none. So we only have volume and surface area formulas. And each of them is only going to use the radius because it's a sphere. Everything is equidistant from the single point. The only measurement that we have within the sphere is the radius, and the radius is always going to be the same. That's it. So the notes are fairly quick. I know that we've seen spheres before, but if you want to take a look, we have some interesting facts about spheres, where we see them in nature. We've talked about how we see them in Earth, and then how we would use them in our formulas. Write down your 3 questions, and I'll see you guys in class.